Space travel has always captured human imagination. From the moon to Mars and beyond, we've dreamed of exploring distant stars. But in reality, current technology isn't quite fast enough to get us there, at least not in any reasonable time frame. What if the key to interstellar travel was hidden in one of the rarest and most powerful substances in the universe, antimatter? This could be the breakthrough that turns science fiction into reality. In this video, we'll dive into antimatter propulsion and explore how this incredible force could revolutionize space travel. Are we really just a few decades away from reaching the stars? Let's find out. Currently, space travel is limited by the propulsion systems we have. Rockets, our most common means of traveling through space, are powerful but incredibly inefficient. Electric propulsion is more efficient but lacks the raw force needed for fast travel. And solar sails are an exciting concept, but they generate only tiny amounts of thrust. These methods work fine for missions within our solar system, but when it comes to traveling to other stars, we hit a major roadblock. Take Proxima b, for example, a planet just 4.24 light-years away. With today's technology, getting there would take tens of thousands of years. But there's hope on the horizon: antimatter propulsion. Antimatter is the mirror image of regular matter, but with opposite properties. Every particle has a counterpart with opposite properties, known as its antimatter twin. For example, an electron, which carries a negative charge, has an antimatter counterpart called a positron, which carries a positive charge. Here's a simple analogy. Think of solving a simple equation like x squared equals 4. The solutions are x equals positive 2 and x equals negative 2, representing opposites. These are opposites of each other, and when they meet, they annihilate each other out, making the sum 0. Just like the equation's solutions cancel each other out, when matter and antimatter come into contact, they annihilate each other, releasing a massive amount of energy. This process is incredibly powerful, and could be the key to generating the immense thrust needed to propel spacecraft to distant stars, unlocking new frontiers. So, how much energy are we talking about here? The energy released when antimatter meets matter is incredible. In fact, 1 gram of antihydrogen could ideally power 23 space shuttles. The energy released from just 1 gram of antimatter, annihilating with 1 gram of matter is roughly 1.8 times 10 to the 14th joules. That's 11 orders of magnitude more energy than burning a gram of rocket fuel, and 100 times the energy density of a nuclear fission or fusion reactor. In theory, antimatter propulsion could allow spacecraft to travel at 70% of the speed of light. This means missions that would normally take thousands of years could be completed in just a few decades. Let's look at something a bit closer to home: Mars. Right now, with current rocket technology, a mission to Mars typically takes 6 to 9 months, depending on the alignment of the planets and the propulsion system. But with antimatter propulsion, we could drastically reduce that travel time. According to research, a spacecraft powered by antimatter could potentially reach Mars in just a few weeks. So, how much antimatter would be required for such a journey? Based on current estimates, about 10 grams of antiprotons would be enough to send a spacecraft to Mars in just a few weeks. The incredible energy efficiency of antimatter means that missions to Mars and beyond could become significantly faster, transforming how we think about interplanetary travel. But before we can make those incredible journeys, we need to tackle some serious challenges, like how to produce and store antimatter efficiently. The first challenge is creating antimatter in the first place, which is no small feat. Right now, antimatter is produced in small amounts in particle accelerators like CERN, but it's extremely costly. For example, the antiproton decelerator at CERN produces about 10 nanograms of antiprotons per year, at a cost of several $1 million. Even if we could produce antimatter, we'd need to store it safely and securely. Antimatter annihilates when it touches anything, so it needs to be kept suspended in powerful electromagnetic fields. The longest scientists have managed to store antimatter is about 16 minutes, but that was only for a few atoms, nowhere near the grams or kilograms needed for an interstellar journey. To make antimatter propulsion a reality, we'd need huge advancements in both antimatter production and storage technology. Right now, It takes an extraordinary amount of energy to produce just tiny amounts of antimatter, and the cost is staggering. Producing a single gram of antimatter could require 25 million kilowatt hours of energy, enough to power a small city for an entire year. Despite these challenges, scientists remain optimistic. Companies like Positron Dynamics are working on creating antimatter propulsion systems, and with enough funding we could see the first antimatter-powered spacecraft prototypes within the next few decades. The promise is clear: a spacecraft powered by antimatter could travel to distant planets like Proxima b in just 6 years. If successful, this technology could change space exploration forever. The future of space exploration is on the horizon, and antimatter propulsion could be the key to making journeys to distant stars a reality. While there's still much to be done, the potential is clear. In the end, it may not just be science fiction. It could be the future of humanity's journey across the stars. If you liked the video, don't forget to subscribe Gnosis Corner for more such contents.